Hello everyone. We are going to start with the next part, that is a machine learning today. Okay, so we'll see the basic concepts related to machine learning, some of the examples, and what are the types of a machine learning. So this part we will cover in today's session. So here you can see the word machine learning, right? So word itself suggests something. Like suppose machine is generally we are calling a machine as a computer. Okay, whatever system we are using or laptop we are using, that we can refer it as a machine, and we are going to train it. So the machine will learn, and based on that it will give us some like analysis or like a prediction, classification. All these things will be there. So whatever terms are there right now, suppose AI is there, deep learning is there, algorithm is there, learning improves. So all these terminologies are related to machine learning only. Okay, so machine will learn, and that will help you to like predict something, to classify something, to have some decision. So all these things, suppose autonomous vehicle is there, that will also come under the machine learning. Okay, neural networks are there, that is a part of a deep learning. Okay, neural network coming under the deep learning part. ANN, CNN, RNN is there. So all these will be the like part of a machine learning only. And suppose data mining is there, you are like extracting a data, you are working on an AI project, right? In machine learning we need to analyze something. Your result should improve. Suppose in first iteration model is giving 60% accuracy, in second iteration it can go for the 70%, 80%, 90%. So for higher accuracy we can go for, right? So all these things are related to machine learning. Basically we are going to train a machine, we are going to build a machine, or we are going to build a model which will be used to predict something in the future. Okay, so these things are there. So basically we will see the what is the machine learning part. In introduction we can say machine learning is a subset of artificial intelligence. What we can say, suppose if we are considering, suppose this is your AI, whole AI part, AI or data science. Okay, artificial intelligence, so it will be a sub part. ML is a machine learning is a subset of artificial intelligence. Overall, on a high level, we can say it as a artificial intelligence, and of which machine learning is a subpart. Other types, like suppose deep learning is there. So deep learning will be a subset of machine learning again, where we will have the like neural networks, artificial neural network, convolutional neural network, or recurrent neural network. These types of neural network are there, which is again subset of a machine learning. So today we are going to focus on the machine learning part. What will be there in a machine learning, what we are doing with the help of a machine learning, what will be the features, or what is the like whole life cycle of a machine learning program. Okay, so these things we are going to cover today. What it does, machine learning enables system to learn from the data. Okay, to learn from the data and improve automatically. So we'll see what is the meaning of this, to learn from the data. Suppose we are just use which data set we know. For example, we know the Titanic data set. In Titanic data set, what was there? There was like a gender of the person, there was the ticket number, age was there, right? Different terms were there, like different features were there. Suppose class of the passenger, all these things were there. And what you are predicting, you are predicting whether
Survived or
person
not
is
survived.
survived or not, survived or not. So that is your target or output, and all these are the features. So this data you have
That
used already, right? Suppose near about 891 records were there, correct? 891 records, out of which you have used 75% for the learning or a training, and 25% you have used for the testing purpose. Why this testing is needed? We can check how much accuracy it is giving. So for that 25% data, what is the accuracy, how model is predicting, whether it is giving you the correct or wrong result, that you can use, sorry, that you can predict, or then that you can evaluate with the help of this 25% data. And if there is a need, you can go for the improvisation. So improve automatically, these things are there. So it enables system, it enables a machine to learn from the data and improve automatically to give the better results. Okay, so Basically, it focuses on machine learning focuses on building a model. Different types of models are there. Suppose linear regression is there, logistic regression is there, k nearest neighbor is there, decision tree is there. Okay, so these number of models are there. At least we are going to cover 10 to 12 models, theoretically as well as implementation. In theory as well as like practical implementation, we are going to cover at least 10 to 12 models. So that building model make predictions or decisions. For what purpose we are using these models? For predictions or decisions. So these two words are different actually. How these two words are different, just take a look. Suppose, just pay attention. I'm having two use cases over here. Which two use cases? Just a minute.
Sir, Tulasi has power cut, it seems. She said she'll join once the power is back.
Okay, no problem, Saranya. Actually, we are having recording as well, so we can share. Okay.
Yes, sir.
Yeah, sure. So there are two use cases. What we are predicting, suppose house price prediction. What is the use case? House price prediction. So you know how will be the house prices? Suppose this is my
According to the
output, right?
area and age.
According to area, according to the age of the house, or like suppose new building is there, square feet, number of rooms, number of bathrooms,
Location.
on location, floor, number, which number floor is, right?
Yes, sir.
So suppose I am having 10 records. What we are having? 10 records. 10 records. So different values will be there. 10K, 12K, 13K, again 10.5K or lakhs we can say. Okay. Right. Again
Yes, sir.
11K, 13K, 14K. So all values will be different. There may be a possibility you will get a 10 unique values. Is it okay? For a price?
Yes, sir.
For a price. So this type of values we call it as a continuous values, right? Suppose I am having 10 records. Those 10 records can be a different, unique one. Suppose I am having 1000 records, so 1000 values may be a different, right? For a similar use case, if I am having 1000 different prices, so 1000 value may be different one, correct? 1 lakh, 1.1 lakh, 1.25 lakh, 3 point, like different values will be there. Similarly, if I am having, suppose person survived or not survived this data for how many records? 1000 records. What values will be there in output? Either survived
Boolean.
or not survived.
survived.
Two values only, this or this. Okay, so binary classification will be there. There may be a possibility you will have 600 survived values and 400 will be not survived. Is it okay? So two types of values are there. One is a continuous one is a categorical one. These type of values we call it as a categorical. Is it okay? So if
Yes, sir.
I'm working on a continuous data problem, continuous output, that could be a prediction, right? What you are predicting? I'm predicting a salary of the person. I'm predicting price of the flat. I'm predicting price of the car. I'm predicting the sale of the product. How much sale can be there? What is the quantity sale? So those values I am predicting. So that could be a prediction. Next can be a decision. Survived, not survived, decision. Correct? Diabetic, non-diabetic. Either diabetic or non-diabetic, that's only. I am having only two choices. Right? Setosa, versicolor, virginica. Three choices are there, but out of three, there will be only one. So that is a decision. For this, it is a setosa. So that decision I am making. So if your data is a continuous, if your target is a continuous, then you are going with the predictions. If your data or like if your target output is a categorical one, you are going with the decisions. Is it okay? Classification model. I hope it is clear.
Yes, sir.
Is it clear? So there
Yes,
are
sir.
some key features for the machine learning. What it does? So it learns from the past data. Suppose 1000 records I am having and I am training the model on 800 records, like 80% data I am using for the training. So it will learn from the past record. So that past record is provided to a model or a machine, improves accuracy over time. Suppose we are having 70% accuracy in a first iteration. So we can go for the adding a new data. We can go for the like changing the nature of the values. We can check for the null values. We can check for the outliers. We can do the various statistical technique. We can do the exploratory data analysis, all these part in order to improve the accuracy. At the end, what we want? At the end, we want accuracy near about a 90%. There is no model, no system which is giving you the 100% accuracy. So that is the ideal one, right? So there is no thing such like we are having 100% accuracy, 98% accuracy, but we can go near 90% accuracy. That is a good enough. Okay. So in actual practice, I'm talking about if you are having ready-made data set or like readily available data set, it may give you the 98 or 99% as well. But in actual practice, 90%, 80 to 90% is a good value for the accuracy. Okay. How many values are correctly predicted? Cover in true positive, true negative, false positive, false negative in this value, right? I've explained this thing. What is the accuracy, right? So true positive, true negative values are giving you the accurate results. False positive, false negative, these are the types of error, type 1 error and type 2 error. Okay. What is the key feature again? It handles the large data set. Whatever is today, that is a big data. Correct? We are working on the like variety of a data. On Instagram, somebody is posting in a text, somebody is posting in an image, somebody is posting a video, somebody is posting a audio. So different types of a data is there. Again, variety of data is there. Velocity, like speed, at a speed, the speed at which data is uploaded and downloaded, that is very high. Okay. Velocity is very high, variety is very high, volume is very high. Okay. Like terabytes of data like is uploaded every second. So velocity, variety, and volume is very high. So that large amount of data is easily handled by machine learning models or machine learning techniques. And it reduces the human intervention. Whatever we are doing, that is a atomized one. Okay. So we can automate the results. In future, we will get the correct predictions, weather forecasting, GPS data, all these things are working behind or in behind the scene. They are using the machine learning things or machine learning techniques. Okay. So this is like more or less introduction related to machine learning part. Now we'll see how machine learning work. So this you can say as a life cycle. Any problem we can define with the help of these steps. Okay. Like how it actually work, or any data science life cycle or machine learning life cycle we can say. So first thing first, what you will have? You will have a problem statement. Okay. So in problem statement, what they will say? They will say like build a machine learning build a machine learning model, to predict whether person is a diabetic or a non-diabetic. Whether person is a diabetic or a non-diabetic with 80% accuracy. So this will be your problem statement only. Your manager, your like peer or your senior will give you the statement like this, and same like whatever data is needed that you have to fetch from the database. Okay. So first thing will be a problem statement. What you are going to do? Build a machine learning model to predict the houses from Hyderabad. Okay. Flat prices from the Hyderabad. So for that you will need a data, right? So that data collection will be there. So most of the time data is readily available, but we need to work on that data. We need to clean it. Sometimes question marks are there. Sometimes like null values are there. We need to take care of all these things. Okay. So that data cleaning may be needed. Suppose age column is there. And that age column, in that age column, what is there? Suppose 10, 20, 21, question mark is there. Sometimes it is written as a NaN, not a number value. So all these things we need to take care. So that thing we will do in a data cleaning part. Okay. Because before building a model, what we need to do? We need to clean our data. The data on which we are going to train a model, that should be a clean. Okay. There should be no noise. Data should not be a dirty. So that care we are going to take. Okay. Next comes to a feature engineering. What features are needed in order to give that output? We have seen in titling data set, we have like drop much columns, right? Correct. Most of the columns we dropped. Like suppose we are predicting whether person will survive or not. So name of the person is not needed. Correct. Ticket number is not needed. It is not based on the ticket number whether person will survive or not. It will not depend passenger ID, whether person will survive or not. So that features, like whatever inputs we are having, okay, in machine learning, inputs are identified by the features. Inputs are identified by features. And what is your output? That output is identified by word, that is a target. Output is identified by target. So these things are there. So we'll see, like in upcoming sessions, we will focus on this feature engineering part, feature scaling, feature extraction, all the feature selection, all these things we will cover in upcoming sessions. Now it comes to the fourth step. 8 steps are there, right? Second is a data collection. Third, we are going to clean a data. Fourth is a feature engineering. Fifth one is a exploratory data analysis. So in short, it is called as the EDA. In some of the like job descriptions for data analyst, business analyst, or like data scientist, machine learning engineer, one keyword is mentioned over there. That is the EDA, capital EDA. It stands for exploratory data analysis. Okay, so in that, what we are doing, overall process. Suppose our whole these steps, 8 steps, we are considering it as 100%. Okay, 100%. So 60 to 70% work we are doing in EDA, exploratory data analysis, to handle a null value, to handle outlier, to detect the outlier. Okay, then handle it. For handling which method you are going to implement, whether you are using a mean of the column, whether you are using the median of the column or the mode of the column, how your data look like, whether there is a skewness in our data, whether there is a distortion in our data, is there, how we can normalize it, how we can convert it into the like bell-shaped curve, normal distribution curve. All these things we are doing in a exploratory data analysis. So number of things are there. We can go for the scaling as well. Suppose you are having the salary values or like profit value, those are like very bigger in nature. Okay, size of the value is very large. We can go for the mean max scaling, or we can go for the standard scaler as well to convert the data into the normal distribution. All these things will be there in a exploratory data analysis. If it is done properly, okay, if exploratory data analysis is done, we are going to build a model in a data modeling. So there are a number of models. Linear regression is there, logistic regression is there, k nearest neighbor is there, decision tree is there, random forest is there. All these models are there that we are going to use for the modeling it, data modeling. Okay, after this, after selecting a model, we need to evaluate it, how much accuracy it is giving. Suppose 70% accuracy my model is giving, that means true positive and true negative values given by the model are the 70% out of 200. Suppose 200 data we have kept for the testing purpose, for evaluation, how much data we have kept? 200. So 140 values are correct, 140 values are predicted correctly. 70%, that is a 140 values. Okay, so that evaluation should be there in order to like achieve the that mentioned accuracy, whatever accuracy the person want from us, or like business want from us, that should be achieved. Okay, we can go for the obviously improving the accuracy, but suppose 70% is also accepted in some of the cases. If it is accepted, we are going for the optimization and deployment. Sometimes we need to optimize, we will go for the deployment after evaluating a model. Deployment, that means which will be used by the end user, or which will be the results, those are visible to the end user or a stakeholder. Is it okay till now? Is it going good?
Yes. Yes, sir.
Yes, sir.
Okay, so these things are there related to machine learning. What we need to like remember over here, machine learning, that means we are going to train our model which will help us to predict something or to decide something in future. Okay, based on the like data which is already available. So we'll just train it. The way we are like training our kid in a home, right? In our home, suppose we are like training our kid, this is the glass, this is the table, this is the TV. When we are saying it a number of times, in future, like in like over the time, moving forward, he or she is like predicting it correctly, right? This is the glass, this is the table. So they way we are like training our model, we are going to or our model is going to learn from that data, and in future it will give us the prediction. So that is how it will work. It's just a natural phenomenon, we can say. Okay, so different types of machine learning are there. We need to focus on three types only. Supervised. Okay, first one is a supervised, second one is a unsupervised, third one is a reinforcement. As of now, there is no need to focus on a semi-supervised. It will fall in between somewhere. Sometime target known, sometime target unknown. So that we can call it as a semi-supervised. But as of now, just try to understand for the supervised. Okay. So in short, I will tell you supervised. That means whatever we discussed till now, person survived, not survived, predict the price of the flat, predict the price of the car. Iris setosa, virginica, three species are there, where output means target was known. Target is completely known. That input output pair is there. This is input and this is output. That your model already know. For this type of input, your output will be like this. So that input output pair is there and target is completely known. So model is working under some supervision. Model is working under someone's supervision. That can be called as the supervised machine learning algorithm, where simple in one word you can define it as a target is completely known. For this input, this is your target. For this input, this is your output. Is it okay, guys? Are you getting this?
Yes, sir.
Whatever we discussed till now, that was the supervised. Okay. What is in unsupervised? Target is not known. In this, target is unknown completely. Target is unknown. Suppose whatever data we are providing, just take an example of iris data set. What is the input? Sepal length, sepal width, petal length, petal width. If we are not giving the last column, that is a species, model will find the similarity into the sizes and it will create the clusters. What it will create? It will
Cluster.
create the clusters or groups based on the similarity. What parameter it will use? Similarity. So it may be a color similarity, it may be a size similarity, it may be a shape similarity. Based on the similarity, it will club your data, it will create a group for your data or clusters for your data. So that is a type of unsupervised. So whenever model is working on the similarity in order to like segregate your data, that will be a type of unsupervised, where target is not known and input output pair is not there, or input output mapping is not there. So this is the basic difference between supervised learning and unsupervised machine learning. These things you need to write. Okay.
Yes, sir.
While making the notes, please like elaborate these things, so it will be helpful in future to understand things in more detail. Okay. And last one is the reinforcement learning, like autonomous vehicle. What is the example? Autonomous car.
One second.
Okay. So it is working on like agent and environment nature. Agent and environment. So there will be some reward type action. Reward policy will be there. Simple. How you will like understand this? It will work on the feedback system. How the feedback is there? If feedback is positive, reward is there. If feedback is negative, like error is there or like punishment is there. Simple. We'll take the like example of autonomous vehicle, autonomous car. If there is obstacle in a road, so environment having the obstacle. So how it working? Agent and environment. Agent is your car. Whatever car is there, that is your agent. If there is obstacle in a road, agent should apply the brake. So that will be a reward, right? Agent should apply the brake. So this type of programming will be there. If it finds the road empty, nothing is there, what should be pressed? Accelerator should be pressed. So that will be again a reward. So the way your model is working like this, that is coming under the reinforcement. Suppose vice versa of this. If there is obstacle and still agent is pressing the accelerator, so it will be like error there, right? So model should learn from that experience, learn from that environment, what was there and what action is happening. So when it works in this fashion, that comes under the reinforcement. We are not going to implement any algorithm for this. Focus on supervised and unsupervised basically. Okay, so these types of machine learnings are there. We'll elaborate it again how it works. Just a minute. So what is there in a supervised? In supervised machine learning, what is there? It uses labeled data input. What it uses? It uses labeled data. Input and output is completely known. So person age is there, gender is there, ticket number is there, parch is there, person class is there, 1, 2, 3, and person survived, not survived, that is given. And we are providing, if in future we are providing inputs, so that will be predicted by the model. But before, like while training the model, we are having the input output pair. For this input, this is your output, right? So this input data is there, and for this the input data, what is the output? Elephant is there, cow is there, and camel is there. So your model should classify the whatever input is there into these three categories. There may be a possibility the elephant is identified as a cow. So that will be error. False positive, false negative error will be there. But whatever you are going to predict, that is already known to your model. So that output is completely defined, clearly defined. Okay, crystal and clear output is there, that will come under the supervised learning. What is the goal? To learn a mapping from the input to output. For this input, this is your output. So that mapping will be there. So goal of a supervised machine learning is to map the input with the output, commonly used for the prediction. So these two words are there, prediction and classification. Whenever your output is a continuous, sales value is there, prices are there, price of something, okay, price of a vehicle, price of a plant, that will come under the this type of problem. Three categories are, that will be a classification. So whenever your output is a categorical, it will come under the classification based problem. For any supervised machine learning algorithm, there are two types, regression and classification. How many types are there? Regression and classification. So simply just remember this word. We will use a regression where your output is a continuous. You will use a classification when output is a categorical. Just try to understand this. These two different words are there. Based on this, whole machine learning will work. Okay. So some algorithm we will use, some processing will be there. Just categorize these inputs into the three different categories. So that's all. Okay. So this will be under supervised. Regression and classification will have a different algorithms that we are going to cover. Suppose example. So on high level, it is a supervised. Okay, I'm just classifying this into the, just pay attention. Which type of there are two types for the supervised machine learning algorithm. One is a regression, one is a classification. What is the difference between classification and regression? Output or a target is
continuous.
Output is
Categorical.
For example, sale, price, correct? For example, diabetic, non-diabetic. Okay, loan approved or declined. Iris setosa, versicular, virginica. Three classes are there. Last example, elephant, cow, and camel is there. So that will come under the classification. Here, whatever examples are given, those are for the supervised. We can classify this like regression. We can use a linear regression. We can use linear regression. Logistic regression will be used for a classification only. Please pay attention. Linear regression algorithm used for regression only. Logistic regression algorithm used for classification only. Categorical data. Other than these two, whatever algorithms are there after this, suppose KNN is there, that we are going to see, K nearest neighbor, decision tree is there, decision tree is there, random forest is there, SVM is there, Suppose XGBoost is there, naive Bayes is there. All these algorithms will be used for both the things, regression as well as classification. So please understand this thing. Remember this. Linear and logistic. Linear is having use case for continuous data only. Logistic regression is used for only and only categorical data, classification based problem. Other than these two algorithms, those are in machine learning. Other than these two algorithms, linear and logistic, other than linear and logistic, whatever algorithms are there, those are having regression as well as classification use cases. Is it okay?
Yes,
Done?
sir.
Have you understood
Yes,
this? Oh, yeah.
So for decision trees and support vector machines, both continuous and categorical will work.
Correct. Suppose I'm predicting the flight price. Okay. The decision tree regressor. What I can use?
Decision.
Decision tree regressor. I can call it as a decision tree regressor. While calling it, I need to define it. In decision tree, there are two modules again, two functions, regression and classification. So if problem is of predicting a flat price, I will call a decision tree regressor. If there is a problem of working with a loan approved or declined, classification based problem, output is a categorical, I will call a decision tree classifier from decision tree. So two options are there. For all these, we are having two options, regression as well as classification. This is single one, linear regression only regression, logistic regression only classification. That's all. Clear?
Yes, sir.
okay, sir.
Okay. Next is a second type is a unsupervised machine learning. So which uses the unlabeled data. So just the raw data is given. Okay. It is not defined, like labels are not there. No labels are there. So it will discover the hidden pattern based on the size, based on the shape, based on the color. It will find the hidden patterns or a structure, and it will cluster the data. What it will form? It will form the cluster. Suppose three types of different groups can be formed. So it will categorize into the three different clusters. It will not name it, not an elephant, not a camel, not a cow, just cluster 1, cluster 2, cluster 3, how many clusters are there. So whatever data you are providing, that can be converted into the three clusters that you will get as output. Okay, so it will, like model itself will find the pattern in the data whatever you are giving. So no predefined outputs are there. So in previous problem we are defined like cow, camel, elephant. It is not defined like that. So unknown output is there, unknown target is there. Target is also identified as a output. So no training data set we are providing as such. So interpretation algorithm will be different one. K-means is there, hierarchical density based algorithm is there. Okay, and after processing you will get output in the form of clusters. In this case, suppose how many clusters can be formed for this data? Optimum number of clusters are 3, correct? For this case, if your model is forming 2 clusters, its accuracy will be less. If model is forming 4 clusters, its accuracy again will be less. When you will know less, when you will get highest accuracy will be
Single
for
cluster.
optimum number of clusters, that is the 3. Sharanya, are you
Yes,
getting
sir.
this?
I mean single cluster for each type. So no
Single
intersection
cluster
between
for
the
each
clusters.
type, correct.
Yeah.
So for that particular data, suppose I am providing iris data, okay. I am just given the sepal length, sepal width, petal length, petal width. No output is there. I just provided the 4 columns. So whatever accuracy my model will give us or give you, that will be maximum for 3 clusters only. If
No
you
intersection
create,
between clusters.
correct. So whatever like completely identified cluster can be formed, that will be your highest accuracy. If you are making it with the 2 clusters, accuracy will be less. If you are making with the 4 clusters, accuracy will be again less. You will get a maximum accuracy for optimum number of clusters, not minimum, not maximum. I am saying optimum. I hope you are getting this.
Yes, sir.
Your model will give you the highest accuracy for optimum number of clusters. Clear? We'll see this. We'll implement the model based on the k-means clustering. You will get a clear idea about this. Don't worry. How these clusters has formed, how we are, like suppose elbow method is used in order to like find out the optimum number of clusters. All these things will be like completely explained in upcoming sessions. Okay, while building a model. Last one is like some model names are there in unsupervised. There are no types as such. Okay, so in clustering we can use a k-means clustering, hierarchical density based. Some model names are like DB scan or ESDB scan model is there. Density based scanning, hierarchical density based scanning. Then dimensionality reduction is there. Principal component analysis is there. Association rules are there. In that we can use a priori algorithm like that. Okay, so we'll focus on this k-means clustering and PCA in our sessions. Okay, we'll use these two techniques, k-means clustering and dimensionality reduction technique. Dimensionality reduction, that means we are going to reduce the feature. Suppose our model is having 100 features. How many features are there? 100 features. So we can make these 100 features into the 30 components, 30 principal components. So whatever data is explained, whatever the like main information which is explained by the 100 features can be explained by 30 components. So your complexity is reduced, data complexity is reduced. So initially you are having 100 features, now you are having 30 components. What I am saying, 30 components. So initially there were 100 columns, now we are having 30 columns. So obviously processing time will reduce, but it will not change your data. Whenever I am applying the dimensionality reduction technique, PCA, it will just reduce the dimension. Initially there were 100 dimensions, now I am having 30 dimensions. Clear? We'll build a model on this. I hope you are getting what we are going to see, what we are going to learn.
Yes, sir.
Yes, sir.
Last type is a reinforcement learning, where learning is happening by interacting environment, where agent takes action and receive the rewards. Okay, so reward and punishment, this type it works actually. What is our target? Cumulative reward it should have. Maximize the cumulative reward for any reinforcement learning algorithm. What are the key components? Agent is there. Okay, suppose in autonomous car is the agent. Outside environment, that is the environment. Whatever action is taking, like applying a brake, applying accelerator, based on that rewards are depend and policy is defined what can be used. Okay, so all these things are with the connection in between agent and environment. So that will be the type of reinforcement learning. Input raw data is there and it will like give you the clear output. So continuous learning process is there in a reinforcement machine learning part. Okay, so algorithms that we are going to build is for the supervised machine learning. Again, regression and classification in that. And in unsupervised machine learning, we are going to build a model on k-means clustering and principal component analysis. Okay, so this part we will cover. Reinforcement, we are not having any algorithm. So if we compare this, if we want to summarize this, what we can use? So if we compare it based on the training data, what can be there? We need to domain knowledge or like expert data label. What can be the label? Right? Suppose survived, not survived, diabetic, non-diabetic, iris setosa, versicular, virginica. That data should be labeled. Where in unsupervised, we are having completely unlabeled data. In reinforcement learning, it learned through the interaction with the environment. Agent learn through the interaction with the environment. Preference is given for the routine task where input and output mapping is there. Data, discovering the correlation and new patterns, we are going with the unsupervised. And when your preference is a completely AI based, behavior learning is there, interaction learning is there, then you are going with the reinforcement. Area is for machine learning only. All these three are the types of machine learning only. Supervised, unsupervised, and reinforcement. When your use case of machine learning, we can use anything. Optimal strategy, if we compare based on the optimal strategy, so depend on the data and the learning algorithm. So it could happen for linear regression, you are getting a less accuracy. For decision tree regression, you are getting a more accuracy. So that completely depend on the data and which learning algorithm you are using. Depend on the Optimal strategy depend on the data and its classification, how data is classified, how many clusters have been formed. Based on that, your accuracy may depend. Again, it learned through the optimal strategy from the experience. So what experience is there? Agent and environment, that experience, that interaction is there, and through that you can decide your optimal strategy. And exploration, actually no exploration is there for the supervised. Again, unsupervised also, it is having some certain limit, but for reinforcement it is adaptable through the exploration to any change. Okay, because it is based on the like experience. Whatever experience is there from the environment, based on that we can go for. So all these things are the for the comparison of supervised, unsupervised, and reinforcement. If we discuss about applications of machine learning, so we can find applications in manufacturing in every sector. Whenever there is a wherever there is a data, wherever there is a data, you will find application of a machine learning. Healthcare, automobile, e-commerce, insurance, transportation, anywhere you will find application to predict the business to like improve or like grow. All these things are there for the machine learning. So this was like a basic part related to a machine learning. We have covered what is a machine learning, what are the steps in a machine learning problem. So from problem statement to deployment, like we are having a problem statement, then we are going for the data gathering or data collection. Then we need to clean that data. We need to do some feature engineering part on that. We need to do the explore the data analysis. We need to build a model. We need to evaluate it, optimize it, and then we can go for the deployment. All these things are there. And again, major part that we discussed today, that was the like types of a machine learning: supervised, unsupervised, and reinforcement. In supervised, again, it is based on the nature of a target. If it is a continuous, it falls under the regression. If it is a categorical, it falls under the classification. Algorithms, those are used for the regression, is a linear regression. Algorithm which is used for the classification, that is a logistic. Other than linear and logistic, whatever algorithms are there, that is having use case for regression as well as classification. In upper unsupervised, model is finding the similarities or like pattern in a data, okay, hidden pattern in your data, and it is creating clusters based on the similarity. So that comes under the unsupervised, where input output mapping is not there, pair is not there. In reinforcement, it completely work on the experience with the outside environment. Agent and environment linking is there, policy is defined, and it work on the like maximizing the cumulative rewards that way. Okay, so these three types are there. Some applications are there. So algorithms we need to remember. So whatever things that we discussed was the related to machine learning. Is it okay, guys?
Yes, sir.
Thank you. Any doubt?
Sir, but we'll take the next class now, sir. Whatever the class we take, if you tell us like what are the concepts we'll be having in that class, we'll have a quick revision previous day and come to the class for better understanding.
Sure. Just a minute. I'm just concluding. So I hope it's clear, right?